It's time for tutorial 4, polynomial regression. Polynomial regression is something that we can use when data is nonlinear. It's not the state-of-the-art technique for that, but it is one that we can really use to learn something about nonlinear problems. Pretty much any regression problem can be made into a linear one using basis functions. Let's see what it does, because it will give us an idea on how to solve nonlinear problems. In polynomial regression, we try to predict y, in this case it's just a scalar y, as a linear addition of polynomial components. Theta 0, constant, plus theta 1, x. Now keep in mind there's like an implied 1 here. Theta 1 times x plus theta 2 times x squared plus and so forth up to theta pxp, which is the sum from p is 0 to p of theta p times x to the power of p. So more generally, in vector form, we can say for each data point I, we have yi is theta transpose times xi, where xi is a vector, for all I. And now this theta is just a vector containing numbers, and this one is a vector containing 1, xi squared, and so on and so forth. Okay, now in linear regression, multiple regression, these would all have been independent dimensions. Here, they're just powers of xi. So we can be back in that matrix form, where we can have y as x theta. Only this part is different from linear regression. Now, all we do relative to what we have before is we replace this, which is multiple linear regression, with this vector. It's a different so-called design matrix. So in the following notebook, you will generate a simulated data set from an underlying polynomial model, build a design matrix with increasing powers, and calculate mean squared error maximum likelihood estimation solutions with matrix forms. And let me just highlight why this is important. So in this tutorial, you will see how if you allow too many of these, if you basically allow lots of different powers here, you will seemingly be good at fitting, but there will be something misleading about it. And this is a nice exercise that gets you to see what the problems are there are. So have fun.